Hey everybody, and welcome to another lecture in logic. Today we're going to be talking about arguments. And I'll define what an argument is. I define it a little bit differently than the authors do. An argument is a statement that is formed from a set of statements, one of which is called the conclusion, the rest of which are called premises. So we have a bunch of statements. One of those statements is called a conclusion. The rest of the statements are called premises. And we put them together and we form an argument. Furthermore, the argument is formed from the premises and the conclusion in the following manner. We have the conjunction of the premises implies the conclusion. This is what an argument looks like. Conjunction of the premises implies the conclusion. So this is the anatomy of an argument. And conjunction. I don't use that word too often, so maybe you don't remember what it means. But essentially a conjunction is an and statement. So if we have two or more premises and we're joining them with a conjunction, we have premise 1 and premise 2 and premise 3 and premise 4. A bunch of premises joined together with and operators. And this conjunction of the premises implies the conclusion, or at least that's what the argument tells us. So just for example, suppose that piece of 1, piece of 2, and piece of 3 are the premises, and Q is the conclusion. Then our argument is going to be of this form. Conjunction of the premises, in other words, P1 and P2 and P3. The conjunction of the premises implies the conclusion. So that is logically what an argument is. Now I'm going to write an argument on the board and I'll put it in a form that you're likely to see. Okay, here's a symbolic argument. And our symbolic argument is made up of the simple statements R, S, and T. So I'd say R, S, and T are the simple statements that make up our argument. P1, that's our first premise. And P1 is the statement R or S. P2, that's the second premise. And P2 is the statement S implies T. And P3, this is our third premise, and P3 is the statement T. Our conclusion Q is the statement that R implies S. Now typically, this is how we may be given an argument. And I should add something else here. This symbol. And this symbol is mathematical shorthand for the word therefore. This is how we might be given the premises and the conclusion for our argument. Now, have I actually written the argument out? I haven't. But here's premise 1, here's premise 2, here's premise 3, and here's our conclusion. So what do we know about an argument? It has the form conjunction of the premises implies the conclusion. So what does our argument look like? Here's what our argument looks like. The conjunction of the premises P1, P2, and P3 implies the conclusion Q. That's what our argument looks like. But our premises P1, P2, P3 are made up of simple statements, as is the conclusion. So really what it looks like, let's see, P1, R or S, and P2, S implies T, and P3, T. So here's the conjunction of the premises implies the conclusion Q, but Q is made up of R and S. Son of a gun, in terms of the simple statements that make up our argument, this is what our argument looks like. The conjunction of the premises, and this is P1, P2, P3, implies the conclusion Q. Wow. That's what our argument looks like. And I think I need to make one more statement. You've heard people not necessarily talking mathematics, but just arguing their point. And one person says such and so, and you should have done this, and the other person says, no, I shouldn't because you didn't, and such and such and so and so. And eventually one person says, no, you don't have a valid argument. In other words, a person is arguing falsely or untruthfully. So just what exactly is a valid argument? I'm going to define that right now. Hey, how are you, Ken?
Right. No, but you're not good luck.
Okay.
Yeah, on the third.
Okay, what room is he in, you know?
Well, we have back office. He always is back.
I'll just go up there and look for him.
Okay, all right. Yeah, all right. He had the red station wagon out there. You look like a man. That ain't it. He's on.
Okay.
All right.
Thanks, Ken.
Yes, sir.
So an argument is valid exactly when it is a tautology. Now, do we remember what a tautology is? That's a statement whose truth values are always true, regardless of the combination of truth values of the simple statements that make it up. Now, notice also that our argument is of the form conjunction of the premises implies the conclusion. So it's an if-then statement. And an if-then statement that's always true, or a tautology, is called an implication. So we can say that too. Now the bottom line is, our argument is going to be valid if we do a truth table for it, and all of the truth values from top to bottom are true. If there's even one false, then the argument's invalid. So that's the bottom line. An argument is valid if, when we do the truth table and we look from top to bottom, they're all true. No falses at all. Now, I just pulled this example out of my socks. I doubt that it's going to be a valid argument, but let's put it to the test, okay? Okay, let's work with this thing and see if we really do have a valid argument on our hands. If we do have a valid argument on our hands, then the truth table for this son of a gun is going to be a tautology or an implication. Our truth table, our statement is composed of, three simple functions, R, S, and T. So when we do our truth table, we're going to have to do the truth values for every possible combination of the three variables R, S, and T. So we'll start with R, S, T, and since we're working with three simple statements, there are 8 possible combinations of truth values. So for R, I'm going to go true, 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 4 of them, and false, 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 4 of these guys. Now, if R is true, S can either be true or false. So I'll do 2 truths and 2 falses. And if R is false, S can either be true or false. So I'll do 2 truths, 2 falses. And now, if T is true and S is true, T can either be true or false. If R is true and S is false, T can either be true or false. Oh my goodness, true or false. So essentially with T we go true, false, true, false, true, false, true, false. These are all of the possible combinations of truth values for R, S, and T. Now let's see. P1 That's the statement R or S. This is an OR statement. What's the special case for an OR statement? An OR statement can only be false if both of the simple statements that make it up are false. So we're going to look for situations where both R and S are false. Does that happen? Let's say, yeah, right here and right here, R and S are both false. False, false. Every other place, the statement R or S is going to be true. We don't even have to think about it. Ah, wonderful. So we got our first premise done. Now, the premise P2, S implies P, or if S, then P. So here's P2, and it's the statement S implies T. This is an if-then statement, or S implies T statement. When is the only time, what's the special case here with an if-then statement? What's the special case? It's only false when we have true implying false. That's the only time that it's false. So we look for places where S is true and T is false. Does that happen? Yeah. S true, T false. So here's one place where it's false. It happens here too. S true, T false. So we have a false here. And I think that's the only place where it happens. Yeah? So every other case, S implies T is true. So we just go ahead and put true here, every other place. Okay, we got P1, P2, P3. No, we don't have P3, but P3 is just the statement T. So whatever the truth values are for T, we'll just copy them over here. True, false, true, false, true, false, true, false. Okay. We have the truth values for each of our premises. We need the truth value for our conclusion, Q. So here's Q. And I may need some room. So let me not take up too much room. Q, that is R implies S. Our conclusion is an if-then or an R implies S. Again, what's the special case for an if-then? See, isn't it? It's only false if we have true implying false. So the only time this can be false is when R is true and S is false. Does that ever happen? let's see, R true and S false right here. R true, S false, R true, S false. These are the only two times when it happens. So we put false here and here. Every other place that statement is true. Now I think we have just about everything done. The only thing that we haven't done is our argument itself. That we have the truth values for each of the premises and the truth values for our conclusion. So we're ready to put all of these things together to form the argument. P1 and P2 and P3. The conjunction of the premises implies the conclusion, Q, okay, well, this is an if-then statement, isn't it? So when is the only time that an if-then is false? It's only false when we have a true implying a false. Does that ever happen? Oh, wait a minute. No, I'm not done yet. Oh my goodness. I am not done yet. Before I can finish this, I actually need to compute the truth value for the conjunction of the premises, P1, P2, P3. Oh my goodness. Well, what an embarrassing moment. I'm glad I caught myself making this mistake before I went further. Yeah, I got to do the conjunction of the premises first. Now, it's a conjunction, an and statement. The only time when an and statement can be true is if all of the simple statements that make it up are true. So if one of these guys is false, the whole thing's false. The only time this can be true is if P1, P2, and P3 are all true. So let's see when that happens. True, true, true. Okay. Does it happen here? No. P2 is false. Does it happen here? True, true, true. Yes, it does. Okay. Does it happen here? No, P3 is false. But it does happen here. True, true, true. Okay, does it happen here? No, P2 and P3 are false. Does it happen here? No, P1 is false. Does it happen here? No, P1 is false again. So these are the only three places where the conjunction of the premises is true. For all other combination of truth values of P1, P2, P3, this thing is false. Okay, now I can do what I was about to do before, but do it correctly. The entire argument, which is the conjunction of the premises, implies the conclusion Q. And again, when is the only time when we have an if-then and it's true? No, that's not what it is it? Okay, you tell me. What is the special case for an if-then statement? It's only false when what? We have true implying false. So in other words, this thing will be false if the conjunction of the premises is true and our conclusion is false. Let's see, does that ever happen? T true, Q true. Okay, not a problem here. Conjunction of the premises true, Q false, oops. Guess what? We got a false here. Did it happen any other time? Nope, just this one time. All of the other times, conjunction of the premises true, and Q is true. Conjunction of the premises true, Q is true. Oh, the only time we get a false value is right here. All of the other times, our argument is true. Oh well, it only takes one falsehood to destroy this argument. So here's what we say. The argument is not a tautology or an implication. So the argument is false. Well, that was a rather nasty example, wasn't it? But if we get a few more of these under our belts, we will become quite good at it. Okay, well, let's look at this example. If you wash my car, then you are a loving son. You did not wash my car. Therefore, you are not a loving son. You know, I sure talk about washing a car quite a bit in this class. Must be something from my early childhood. So here's our argument. P1 is the premise. If you wash my car, then you are a loving son. P2 is the premise. You did not wash my car. And Q is the conclusion. You are not a loving son. Now, I should identify my simple statements first. Let's see, you will wash my car. So we will call that R. And by the way, when I do these arguments and I call P1 and P2 my premises, and I call Q my conclusion, I avoid calling the simple statements that make up the argument P and Q, because I'm already using P1 and P2 and Q for my premises and conclusions. So when I identify my simple statements, I'll start with R, just so that we don't say, wait a minute, here's P and here's P1, I'm confused. No, for our arguments, I'll let the P's and the Q's be our premises and conclusions, and my simple statements will be R, S, T, and so forth. So our simple statements are, you will wash my car, you are a loving son, so let's see, we'll call that S. And wow, that's it. That is it. No more simple statements. Okay, this is a pretty easy argument. So symbolically, if you wash my car, then you are a loving son. That's R implies S. That's P1. P2, you did not wash my car. So that's the negation of R, isn't it? R is you did wash my car, or you will wash my car. So you did not wash my car, that's the negation of R. And Q, you are not a loving son. So let's see, you are a loving son is S. You are not a loving son, that's not S. Okay. So symbolically, here's the form of my argument. Let's see if this argument is valid. Yeah, we construct a truth table for the argument. And remember the form of the argument? It's the conjunction of the premises implies the conclusion. So we're going to do a truth table for this statement. And we only have two simple statements to make it up. R and S. R and S are the only simple statements. So we go true, true, false, false, and true, false, true, false. And now, what's my first premise? Piece of 1, that's R implies S. So this is an if-then or R implies S statement. When is the only time that, let's see, what's the special case for an if-then? An if-then is only false when what happens? An if-then is only false what? When we have true implying false, right? So we look for a case where R is true and S is false, and here it is. P1 is only false when we have R true implying S false. Every other time this statement is true. Okay. Now P2. Not R, or the negation of R. This just changes the truth value of R. It changes trues to false, and it changes false to true. So there's P2. And our argument is of the form P1 and P2 implies Q. Okay, so I guess I need to get the conjunction of P1 and P2, right? P1 and P2. It's a conjunction. It's an and statement. What's the special case for an and statement? The only time an and statement is true is when each of the individual statements that make it up are true. So we look for a case where P1 and P2 are both true. And that happens here, and it happens here. Okay. Every other time, it's false. Now I need Q. Q is the negation of S. So I just take the truth values for S, true, false, and I switch them. I have false, true, false, true. Whoops, let's see. False, true, false, true. Okay, let me just check and make sure I'm right. True implies false. Okay. Not S, false, true, okay. And I think we are ready to do our argument. Our argument is the conjunction. Our argument is the conjunction of the premises, P1 and P2, implies Q. And we have P1 and P2. We have Q. So let this let's see what happens here. It's an if-then statement. What's the special case for an if-then statement? It's only false when we have true implying false. Does that ever happen? It does. Here we have true implying false, so that's false. Now all the other times it looks like we have true, but this one case we have a false. Okay. Well, guess what? The argument's invalid. If we don't have all truths here, the argument is invalid. So I'll write that. Since the argument is not a tautology, and that is, in this case, also an implication, the argument is invalid. The argument is invalid. And I will encapsulate that oh, thank goodness. You know, I guess I don't have to have a heavy conscience because of that time when I was 9 years old and my father told me to wash the car and I didn't. I guess I'm forgiven. Now, we do all of our arguments exactly this way. We find the truth values for each premise, and then we take the conjunction of the premises, we take the conclusion, and the conjunction of the premises implies the conclusion. We do the truth values for that statement. And the only time that the argument is going to be valid is if we have all truths here. If we have even one false, the argument is invalid. Now, I know you're eager to get going on these exercises, so I will stop the lecture here and send out the video and the homework assignment by email.